Yes, indeed. So I suggest maybe also take some more general questions from the audience, if anyone has any, that the speakers might be able to answer. So please type them in Zoom as you've done so far. Right, now let's see. So to get this one started, as people gather their thoughts, then so you know, just inspired by your presentation that I thought was very interesting. So at the moment we are focusing a lot, at least in the vision side of things, in reconstructing 3D shapes, meaning we want to get something like 3D mesh, basically an idea of the surface of the object, maybe also the appearance. That would be the BRDF. But there's much more that we can understand. We should be understanding about objects. There is the concept of part. There is the concept of category. So, you know, how these things connect through many different object instances. Then there is a notion of dynamics, which we didn't discuss almost at all. I mean, there were some papers that show that at the level of deforming a mesh, but that wasn't explained in terms of, I don't know, skeletal structures, for example, or, you know, muscle control or anything like that. So there isn't really a very deep understanding of these dynamics either. But what you showed here was some work that was trying to parse an image or into a set of primitives in a way, right? But those primitives, they do not appear to be very semantic yet, not very meaningful to a human necessarily. So how do you guys feel about moving to the next level beyond just understanding 3D shape in a shallow manner? Maybe going to understand also the 3D structure and the physicality of the objects in terms of parts and you know, some sensible decomposition of the object in something that actually makes sense.
I think this is a really interesting question, and one that we have in our long-term agenda. So if we think of the sequence of operations, right, and if we start taking snapshots when users are modeling it, so we don't have the final shape, we have the progression of the models as people are creating the models. I think that gives a sort of a semantic association of how the parts are growing or how the parts are attached to previous ones. So there is also a temporal aspect of this, of how, not the dynamic of the parts, but how the parts are attached. And most of the semantic justification would be the core parts are introduced first, and then the details are formed, and how and capturing the correlation of the parts would be a nice aspect to have.
So correlation between, so you mean statistical correlation?
Statistical correlation, yeah, right. How the parts are connected. Like if taking say Yasunas's example that he was saying, like if you have animals, the body size is certain size and proportion, then the legs or the limbs that are getting attached to that has a certain relation with respect to the primary body and where they're located in terms of both the number of the limbs as well as the proportion and size of it. I think we're quite far from that. First step would be the dynamics of it before we talk about the evolving of the parts.
Okay, anyone else wants to say something about, you know, parts and structure in the objects? Not really. Okay, all right. I don't. By the way, so I still don't see any question in Zoom. So if the audience would like to type some questions, that's now would be the time to do that. Right. So moving on then. So one issue that is that well, a lot of the work that we're doing, not all of it, but especially when it comes to deformable objects like, you know, animals, horses, and complex things like that, where you can have a complex set of deformations, they still seem to require some form of initializations, which is manually guided at least at some level. Now, yes, as you were saying before, that you can do your modeling without having a manual input, I guess. But my understanding is that at the moment, you're still at least basing your work on some sort of initial template. Is that right?
It's right. Still, I think that there was a very interesting work in CBPR21 and now in URIPS21 coming from CMU, from Deva Ramana's group and Jameson, I think. which was about taking a video and lifting it in terms of an articulated
laser.
Laser, yes, laser, and now it's visor. So
yes.
This is, prior free just starting from a Gaussian, but then branches off into more Gaussian. So it's like effectively learning it all from scratch and handling articulations and challenging motions. So I think this is very exciting in the sense that we can say this could be used to learn categories too. So, and also from classical non-rigid SFM, you can very well do it without any template.
Excuse me, what can you?
I mean, from classical non-rigid SFM, as soon as you have dense correspondence, you can learn it without a template.
Yes.
It's, in principle, it's very well doable.
But in that case, you will need a dense pose for initialization. So how much can you get unsupervised, and how important do you feel that is? So we tend to use a little bit of supervision, for example, at the very least in terms of getting a segmentation of the object in the image. Again, not all the works do that, but most of them do, right? There is a baseline level of supervision, maybe 2D supervision, not 3D supervision we are injecting into the reconstruction process. How do you think we can get rid of that? How do you think that's very challenging? Is that important to do, or is just wasting time trying to do that?
I think practically what we're all doing is taking what we know from computer vision, using it as self-supervision. So we know how to do video processing, or we know how to do classic geometry, and we're saying let's use it as a DOS. So in that sense, the more we can exploit from vision, the better. So let's say these techniques effectively use supervision in the form of asking you to have a video, which is something beyond the minimal thing of just throwing images at it.
Right.
So the more we can put in without, I think the balance is how much effort is required on the computer vision side to do it versus what is the improvement you get in your models. So if you go out of your way to get some computer vision thing to get a marginal improvement, it's maybe not worth it.
Okay, that's a very practical way of looking at it, but in principle, so as scientists, do you think that removing supervision is an interesting problem?
Maybe it's just maybe it's just me, but as soon as I'm having a hard time following your audio, maybe you can speak closer to the microphone. It's been also like
maybe better now.
Your talk.
Yeah.
Sorry about this.
It's better now.
Yes, it is better.
So I'd actually want to add on top of that. So for example, when you talk about the template, I think the traditional notion of template has changed to some extent. For example, if you view NERF, right, as a representation, and to some extent, IBRNet will serve as a template to some extent, because if you pre-train a network, right, that adapts to different models, then for new models that resemble similarity, it actually serves as a de facto template. So our recent experience is that we have very interesting experiments. For example, if we pre-train an IBRNet for different, human performing different, actions, then you pre-train that, and then use that as the IBRNet, and then you have a new set of performers, and you will find that actually you can benefit tremendously from your pre-trained IBRNet for both reconstruction and the view interpolation. So this is one thing I think, potentially in the future can benefit from quote unquote templates. There are other interesting things. For example, pose itself can serve as a template, meaning that if you have some kind of like a quote unquote pose net, you've seen different poses before, then you can actually use that to very quickly determine the pose of in the, for example, SFM settings. So in other words, my feeling is that, especially with respect to, human, 3D reconstruction, is that actually the notion of template is, migrating towards a neural template than the traditional sense, Actually, on the contrary, I find it increasingly challenging to incorporate traditional, physical-based or, stereo-based constraints into the network versus an implicit way of doing that.
Okay, that's very interesting. So, do you guys agree that we are losing the symmetricity, or if you like, the interpretability of these templates or priors we inject into these models? And is that a good thing or a bad thing? Yeah, please.
I think for some things it's we should. My belief is it's not good to give the network extra freedom that we need to. Like for something like the camera model, if we know it, we should have that as a base model, and at best give it a residue on top of that. But something like was mentioned, like there's a lot of ambiguity in the image formation model because going from 3D to 2D. So we definitely lose certain things. If we are doing a single image reconstruction, for example, then there has to be a supervision in some form. Right? So I think we might want to distinguish between, is it the supervision in terms of annotation data, or is it supervision in terms of maybe some object detection level, or someone has grouped the objects like these are all objects of humans or an alien creature, etc. But it seems hard for a network or any method for that matter to generalize from human to a completely different organism that has like an entirely different structure. What does even generalization mean there? Yeah.
So how are we going to understand every animal in the world in 3D? Or as a matter of fact, any object in 3D. Like, you know, David has his data set of 50 categories, which is great, but 50 is less than many millions of categories that are out there probably, or at least hundreds of thousands, right? So how do we scale this up to understanding?
I think just to say that because something David very specifically made a point that even the choice of 50, which 50 would determine because Cocoa segmentation was pre-trained on that and available. That's how we picked this 50, right? So it's not like 50 random objects. So there are things that, as you said, the bootstrapping would become a challenge, and we need one more loop to go out of that.
I see.
Yes, also.
Yes, it is true that to some extent we have to challenge the notion of the object category by itself, right? What is actually object category? Is it just something which we can reconstruct? Is it something which is grouped somehow based on semanticity, things like this, right? So I don't know. My intuition is that we can learn like very high-level priors on the reconstruction, but I wouldn't really necessarily make them completely like tied to the categories themselves, because I think with time we will basically run out of the reconstructible categories, although you would still be able to reconstruct other things. So it seems like quite restrictive to, in my opinion. Yeah.
Okay, that's an interesting point. So we could just get rid of the concept of categories, and then we would be done. That's actually.
Well, no, I'm not saying completely. No, like I mean, sure you can use it to like initialize the reconstruction pipelines and stuff like that, right? But like with time, you will find out. Or actually, what I found out from the experiments is that these things always learn very like, generic reconstruction like priors. They don't really learn anything about the category very well. For instance, the IBRNet is a good example. We have been speaking about this here. It's literally like a multi-view stereo machine. It doesn't really learn anything about like a object category, even if you deploy it on a category-specific data set. It's very low-level thing. I feel like most of these like category-centric reconstructors actually latch on very low-level like cues. So yeah, but I agree that the notion of the object category, for instance, helps you to, let's say, focus on one object in the scene, and then like it gives you these like nice constraints, so like a multi-view, like a reconstruction, signal, which is very hard to achieve in like constrained scenes.
Okay, thank you. Anyone else wants to interject on this question?
Yeah, I just want to say that, understand is maybe general, like it depends on what we want to do afterwards, right? So one thing is reconstructing 3D, but let's say for anything like humans in particular, or anything you would want to insert in a downstream task like augmented reality, you need to have things which are interpretable so they can be used. So if it doesn't come with a template, you cannot have creators or anyone who's coming from the graphics background try to wrap their head around an implicit model or anything like that. So it's already hard enough with articulated objects, with templates for articulated objects.
So you're saying that just the application itself means and implies that you're going to have some sort of template at some level. It's just because the reason why you're doing this, the performance reconstruction already has embedded a notion of template, like for example, the need for manipulation.
Yes, I think it's the same kind of questions you have for segmentation. Like, can we do segmentation? So it's largely task specific. So the kind of 3D understanding we want to do may be largely determined by the domain in which we want to do it.
Okay, I see. All right, anyone else on the question of scalability? Okay, if not, I can move to maybe another question. So Andreas, there's something you said before that struck me actually. So you said that you are very focused in improving the quality of the rendering now, as opposed to, I don't know, understanding, developing an autoencoder architecture so you can parse an image instead. So there is this sort of, well, I wouldn't say a trade-off, but maybe a different focus. One could be just, let's improve the rendering quality so we get really, really nice images, which almost feels like a computer graphics task. And then there is a computer vision task, which is understanding the images means performing good reconstruction, maybe understanding the structure, the semantics, etc. So how do you guys feel these things are connected? Is it really important to get pixel perfect reconstructions to be able to get solid semantic reconstruction, or can we develop these two things somewhat independently?
Well, that's a good question. I think what is striking to me is that like taking independently 2D generative models are pretty capable of fooling humans. And also, if you have the right scene, it doesn't work for all the scenes, but if you have the right scene, then novel view synthesis methods also work quite well. In some scenarios, they don't work well. So we tried, for example, we tried Nerf on Kitty, and it doesn't work very well. But if you have the right scene, it gives you photorealistic results. And so it's a little bit striking to us why bridging this gap is so hard. And so that's, I think, in theory, it should be possible. The question is, do you need it? I think this was behind your question. I think it also depends on the application, right? So you like we are. So I'm personally interested in building simulators, and the question is also for simulators, does it need to be photorealistic? I think simulators can operate at all kinds of levels of abstractions, but one level of abstraction that you also, I think, will need in the end is a photorealistic level of abstraction, and for this I think you need to have this. And my experience with things like novel view synthesis is that if you can't get the geometry exactly right and the scene is non-trivial, then the novel view synthesis will also not work. So basically the reconstruction loss, the RGB reconstruction loss, is quite a decent proxy actually to how good your reconstruction is, and vice versa. So I mean, for non-trivial scenes, if you have a trivial scene like something planar or something very simple, then of course this doesn't hold. But as soon as the scene becomes like very complicated, where you have like, look at a fence or something with very intricate structure and occlusion relationships, then things really start to matter. And yeah, but I agree. I mean, it depends on what you want to do with it in the end, right? So maybe one comment to the previous discussion. I mean, most of what I would have said has been said already, but I also feel like we need to, of course, get away from this object-centric reconstruction. And I mean, for example, for single image depth prediction, this is happening, right? You can, if you look at scenes, general scenes, you can't even identify all the objects. Sometimes an object is not clearly defined. It's not clearly defined if something is belonging to the stuff category or is belonging to the object category. We had a lot of trouble actually annotating our data sets because there can be buildings with vegetation on it, and there can be vegetation that's standalone, that's more like an instance, and there can be all kinds of intermediate things. And so it feels a little bit artificial to actually define this. And the question is, do we actually need to define all of this? I'm wondering.
So we are abolishing categories and objects today. So a good 20 minutes, I think, of research, right?
Well, I mean, maybe we don't need to abolish it, but ideally it would come automatically, right? Ideally, we don't have to define it ourselves, but it would be defined based on a downstream task in an unsupervised way from the method side, right? Not from us as engineers, I would feel.
Yes.
I actually echo Andre's comments actually. So our group has also tried very hard to apply Nerf to outdoor scenes, but not that successful. So we actually observed the exact phenomena as you just discussed. And my speculation to some extent is that the nerf tends to overfit, to the images. And as a result, the sampled views actually do look pretty reasonable. But especially in the sparse settings, we figure that actually the geometry reconstruction or view interpolation, can be a disaster if you only have a sparse settings. So my students, have this interesting speculation that saying, it's always a balance between geometry reconstruction and view synthesis or rendering. So in other words, if your emphasis too much on the rendering part, actually, there's a possibility your geometry will degrade, as you improve appearance, if you use just appearance loss, So this is a phenomenon we observed, even beyond outdoor things. We actually try that on something called a crowd ET image. It's a bio image, and we observed the exact same phenomena. The better rendering you get or meeting fitting, on the sampled views, it turns out because under sparse settings, then we observe the geometry reconstruction gets even worse. So I don't know how to, mitigate the problem. Maybe Andreas knows better about it, but I echo your point, on what's going on. Another interesting thing is that I think, semantic meanings is really useful in generation tasks, but in the reconstruction task, as you mentioned, it's kind of tricky because how do you define semantics? In the generation task, it's very clear, right? Because you are given a semantic map, then you synthesize, multi-view images, blah, blah, blah. But in the reconstruction setup, it's getting much more vague. So, and more challenging speaking, when you have a dynamic objects, then how do you actually maintain the same semantic meanings across deformations, which it seems to be very, very difficult, especially in the nerf-based reconstruction tasks. So these are just my 2 cents.
Okay, no, that's great. Thank you. Thank you very much. So we only have maybe 1 minute left, I think, indeed, exactly 1 minute. So is there anyone else that wants to, that's your last chance for a comment, I guess. So please.
I think I think it's okay if we run over a few minutes, but in case if anyone wants to leave, I think it's fine, but we can extend this for a few minutes.
Okay. So, well, I
think maybe before jumping to conclusion too fast, about photorealism and the geometry trade-off, that I think I also agree there is a trade-off there. Sometimes we should also revisit the model we are using. So in the amazing work Andreas showed on giraffe and also graph, there are object-to-object interactions. So when we stand, there is a shadow on the ground, right? And that this is a very simple one. If you do outdoor, I would imagine someone taking the picture would cast a shadow. I think in the example that David showed of this yellow hydrant, there was a shadow of the person on top of the hydrant as he or she was capturing. And this is not captured in the model, but it's there in the photo, what we have observed. So even if the model, either we have to improve the model or we need another step in the algorithm, in the inductive bias to model this as outlier. So there's a trade-off of increasing the set of assumptions on the scene versus how much we can handle at optimization time.
I think I also want to add a point. I think there is a missing bridge between geometry and appearance. If we have if we can complete the bridge, all the appearance results from the geometry, right? All the shading effects, specularity, if we can actually model all these appearance effects, I think ultimately this should also benefit for the geometry reconstruction. It's just all these effects, they're extremely hard to model unless we're using Lambertian assumptions, which are probably it's the best model we can use at the moment, or foam models. I think this is like something that's missing to bridge the gap between geometry and appearance.
You mean better illumination model, better reflectance models?
It's hard to model all these like shading effects, but if we can like model it better, it should be like all these appearance should give us much more information about the geometry itself as well.
So I think you're right. You know, I will add on top of that. You know, again with our own experience. You know, I think whenever we talk about shading and materials, right? It's very closely related to normals. So then this is actually when you talk about the gap, right? Then I think I call it a normal gap, meaning that under the, for example, the NURF setting, it's essentially a density field, right? It's a volumetric reconstruction. So you can use, for example, SDF, which is one way of kind of extracting the normals. But essentially, it's if you view it as a level set, right? So how do you extract different level sets and its corresponding normals? It still remains an open problem. So when you say you want to make this gap, you want to bridge a gap. Essentially, I think we need to first bridge a gap between density field and the normal field. I think this is the first urgent task to accomplish. These are just my very biased views. So.
My intuition behind like better material models is that you are giving actually the model a lot of chances to cheat by producing all these like different peculiarities and reflections and stuff like this, right? So I would agree that definitely like a good material decomposition is extremely important. At the same time, regularizing material decomposition so that the model doesn't present like specularity with some kind of a change of color, local or something like that. That's extremely hard, right? So people have to be very careful in that case. Yeah. And adding on top of that point between like a correlation between the appearance and geometry performance, I would definitely say that the correlation was pretty obvious in our experiments on the code-3D dataset. Really across all the baselines, we found out that the depth reproduction accuracy was perfectly correlated with the accuracy of the generated color. So it really seems that the models really have to understand geometry perfectly.
Okay, great. Now we stick it for a while, but we're probably a bit out of time now. So we should probably take this to a close. There will be a second panel later.